All right, welcome back. In this one, we're going to be discussing time series queries. And that's basically exactly what it sounds like. Um, if you have data in your containers that are of the time series variety, there are a number of ways you can query that data to grab exactly what you're looking for. You can compare to, you can, for example, select all time before right now, or you can select a bunch of stuff. So we'll just go over that. So let's just get into it. All right. So to get started, let's just go over some very simple time series queries first. So these are some time type operations that you can do if you have a time series container or data that has time series data in it. Um, so for example, you can use now, which will just use the current time as a basis for your query, which makes it a simple way of saying, comparing against time to your current time, basically. A second way is you can use an actual time. So if you type in timestamp and then in the parentheses put in a specific time, that'll also be valid in your query. So you can say, give me all data from after this very specific point in time, and of course the query will find that for you. You can also do very basic calculations of time data. So for example, here there's one called timestamp add, and you can see the parameters required. So time unit, here you can do like second, minute, hour, day. I think that's everything. And then timestamp is just the time, and then you do the duration. So in the example here, it says select all columns where the date is less than, and then we did a timestamp add. And for the time unit, we did hour, so it'll search by hours. And then timestamp is now, so you don't actually have to find what the current time is. You just use now, which is very useful. And then -1. So basically, it'll find all the values from an hour ago, basically. So it's a very easy way of trying to, query time. Another one is timestamp diff. You can see here it's going to find the difference between two timestamps. So you can see the parameters takes two timestamps. So you can select all data where, so basically, if there's a difference between 10 hours, you can see it's less than 10. So if difference at 10 hours between the end and start times, that's all the data that we returned. So it sounds kind of confusing, but once you kind of get a hang of it, it's actually really easy and intuitive to query these time series data sets. All right, and a couple of more time type operations that are pretty important to know when you want to be conducting some querying on your data sets is these two here. It's two timestamp ms, and this one takes a number as a parameter, and the other one is two epoch ms, and this one takes an actual timestamp. So the top one, there's a sample query. So you select all columns where, and then you boot two timestamp ms. So in the num parameter part, you would actually enter in number in milliseconds from epoch time, which is, you probably know, it's 1970, January 1st. So in this case, I will show a hands-on later, but essentially you would put in this huge number, this milliseconds of time since 1970. It's a standard programming number. The only issue with using this is that if you try to put a number that's really, really big, that doesn't correspond with an actual valid millisecond time, you'll get an error. Or if you also do like a negative number, you will also end up with an error if you try to use this two timestamp ms query. So I personally don't think it's that dangerous of a concern. So I think if you're using this command, you would know to use the milliseconds in time. But two epoch ms tries to solve that problem, so it's kind of backwards from this. So instead of using the milliseconds time, you would actually throw in a timestamp. So you can see in the example, select all columns where, and you would throw a number in there, like milliseconds time again, and then this time we're using the now command, or the now variable, I guess you could say. So now just is a timestamp for right now. So 2 epoch ms takes an actual timestamp, and 2 timestamp ms takes milliseconds. So those really help with querying your time data. All right, so now that we've gone over the more simple type of time operations, let's look into selection and interpolation. So these are a little more complex and equally as useful though, okay? So let's check them out. So one, for example, here is called time next. So this one will select a row with either the identical timestamp entered or the closest available timestamp. So this one is kind of nice because you don't have to be exact in your timestamp estimation. Because if you have timestamps that are, down to the minute or second even, sometimes it's kind of hard to pinpoint exactly where, you want your data. But if you have a time next, you can kind of ballpark it. So in the example query here, we're selecting from 2011, July 1st, but we didn't set a time, but it doesn't matter. So if it exists at that time, it'll find it. And if not, it'll find the next newest from that point. And that's similar to time next only. This time it's the same thing, but it will not find the identical. So even if, for example, it's the same query, but this time we added the only qualifier, even if that exact row key exists, we'll skip that and go to the next one. So kind of do the same thing, but there's that big difference that can really change how you want to use both of these functions. Next up is the same things, but for previous. So I just combined them in one. So there's time previous and time previous only. So same idea as before. So time prev, I'll just say the whole thing. Time previous will find, if it's identical, it'll find that row key, or if it can't find that exact row key, it'll find the one previous to that. And then prev only does the same thing. It will not find the identical. It will only find the timestamp prior to the one that we entered into the query. Next up, we want to discuss the aggregation operations. These maybe aren't quite as common as the ones before, but obviously very important in their own right. First one we want to talk about is time interpolated. So to run this one, you would set the column name you want, and then you would do a timestamp. So I'll just read this. So it says selects row with identical or finds value by interpolating values adjacent rows whose timestamps are just before and after the timestamp chosen. So here's a sample of how you would run this query. So you do select time interpolated from column voltage 103, and then you put a timestamp from plant 1. So basically what it's saying is it tries to find rows around this timestamp. So even if that exact timestamp doesn't really exist, it'll find all the rows adjacent. So just before and just after, depending on how close or not close you are. So it really helps with, you don't have to know the exact timestamp of every query you run, just ballpark or so, and you can interpolate from there. Next up is time sampling. So this one's a bit more complex. So it takes a sampling of rows in a specific range from a given start time to a given end time. So you can see in the parameter list, first is columns, and then is timestamp start, timestamp end, the interval, and then the interval you can do minute, hour, or seconds or milliseconds. So the example query here is select time sampling from voltage 103, same column as before, but now we have a range of time, right? So now we have July 1st at 0 o'clock, midnight, to July 2nd, midnight as well. And we want the interval to be 1 hour. So basically, it'll find all the data between this data set that we choose. So from July 1st through July 2nd, every hour it'll give you the timestamps that are in that range. So again, if you don't really know the exact timestamps you're looking for, if you're dealing with aggregation, you want to grab all those rows and see all the data within that time period. Yeah, you can use time sampling, and it really makes things easy for you. All right, and the last aggregation operation I want to go over is the time average. So as you can see, it only takes one parameter. It's just the column that you want to find. And the time average returns the average weighted by a time type key of values in the specified column. And so this value was always going to be of the double type because, as you know, averages always have decimals in there because they're dividing numbers and doing lots of math in the background. So here's an example. So let's say we want to find the average voltage from plant 1 in the month of July 2011. So you would write your query like you see here in the bottom. So select time average, and then you put the column name voltage 103 from plant 1, and then you just select the timestamps you want to query against, and that's just the month of July. So July 1st through to August 1st, and it'll give you all the value. It'll give you basically the time, the average, the weighted average of voltage 103 in that time span. And so the weighted average is calculated by dividing the sum of products of sample values and their respective weighted values by the sum of the weighted values. So that's basically how it works. All right, so this is our time series hands-on portion. So we will be running through some of the queries we discussed earlier, but with a real-world example. And we're using the GridDB CLI tool to, it's the easiest way to kind of showcase these things. So we're going to be querying against our data set that we ingested before. So let's just get started. So I'm just going to copy and paste these to make it easy for everybody. So this one I'm actually using SQL first, but generally you would use TQL, and I will move on to TQL after this. But first I'm using the SQL query. So this is a timestamp add query. So basically here I have, let's change the month to minute actually, because this time series data set is mostly on a minute per minute basis, not really a month kind of thing. But anyway, so here I want to select, let's say I have a time period that I specifically want to query against, which is July 12th, 2020 at 11:22 o'clock. Let's change this to, let's say 10 minutes. Basically, when I run this query, it'll run this, it'll find the time from this time, but it'll add 10 minutes to that. So let's do this. Let's just get the 1. And you can see here, I queried 11:22, and the result I got was 11:32. Yeah, not that exciting, not that interesting, but that's how it goes. Timestamp add. Next, we're going to use the TQL, like I said. And this time, instead of saying from device, from container name at the end, like a SQL query would, we kind of put everything up front. So TQL, container name, and then you run your query. So right now, we're just selecting all columns where the timestamp is greater than now, which is going to be 0 because that doesn't exist right now. It's not live streaming data. It's just old historical data. But of course, if you were to reverse this, we would get all our rows, of course. So yeah, not that interesting either, but that's how it goes. Another one here, TQL again, select where timestamp is greater than, and then this time we actually have a timestamp in there instead of now. So if you want to have a specific timestamp, I think I need to remove this. If you want to have a specific timestamp, yeah, you can actually explicitly state timestamp and then give a timestamp. So let's do that. And now you can see here our results are not everything. So we filtered out about 6,000 rows by specifying explicitly, you know, this time period. So let's say if we change it to 32, let's see how many rows get cut out. So yeah, about what you would expect, right? Okay. Let's march on to the next, which coincidentally is called time next. So this one is, as I stated before, it pulls the identical value, or if that doesn't exist, it pulls the next value. So I believe this timestamp I'm using, it does have an identical value. So if I grab this, it doesn't like this for some reason. Let's see, what did I do? Select time next. Oh, I have the extra quotation mark here. Okay. So get one. And yeah, you can see here, it actually doesn't have the exact time. It actually has this. So it's actually doing time next, basically. So let's try to clean this query up a bit so it's a little more clear. Okay, so let's change. Let's just only find the time stamp, and let's change this to be an exact match. Let's run this again. Okay, let's not specify column. Okay. So you can see here it pulled back the exact same row, right? Of course, because the exact time row exists. So now we can add time next only, and this one does not get the exact value. So it'll be, even though we're having the same query, since that row key exists, it'll push up to one after. So if we look at this now, you can see the values are not the same. So this is the next time up from the previous query. All right. Now let's try the other commands. I think we're gonna do. Let's see. So yeah, next I want to do the to timestamp ms and the to timestamp epoch. So I have them saved here. So I'll explain a bit. So the to timestamp ms takes milliseconds since epoch as the parameter, and then you're using that as your timestamp that you want to query for. So if you're unfamiliar with what this number represents, it's, imagine in 1970, January 1st, they started this time since epoch. So basically, if you count milliseconds from that exact time till now, that's this value. So I don't know how big this number is, but that's how many milliseconds have passed since that point in time. So to get this number, for example, you can use whatever. So I usually just use the JavaScript. You can do, like, for example, you can do now is equal to date now. And if you run this, so this is basically, this is a universal concept. Every programming language uses this. So we can input this directly into our query, and it's basically like querying against now, except for the time is kind of marching on as the longer I talk. But yeah, so then yeah, you can query this. So select all times that are greater than this compared to this timestamp here. So yeah, it just gives us everything. So yeah, we can check. And yeah. Okay. The one caveat with this, with using milliseconds since epoch, is if you wanted to do a time period from before 1970, you start getting into negative numbers. So if you wanted to do like 100 milliseconds before time of epoch for some reason, and you did minus 100, you get an error, invalid argument range. Or if you want to, for some reason, have like this ridiculously large number, yeah, it also errors. So if that's the case, you have the alternative is the epoch ms. So this command, instead of using milliseconds since epoch, you actually use a timestamp. So if you run this now in the TQL, it gives you the current timestamp in a nice timestamp format. So this will run and it's valid. So select all where this time is greater than now, which, you know, is not true, so no results. Yeah. All right, let's see what else we can try to query here. Actually, I think that's it. All right, so actually I lied. So there are a couple of more commands we can try. Notably, we forgot to run through the aggregation queries. So let's just go ahead and do those first. First, I'll do the time average because it's very simple. So let's do time device2 select time average, and then yeah, we'll stick with humidity because it's there. But basically, yeah, this is going to bring the weighted average of humidity amongst the entirety of the data set. So it'll run through and do all the math for us in the background to find that weighted average of humidity within all 111,000 rows. If you hit this, you hit get, and you get 75.415 or whatever. So yeah, as I said before, the values are always going to be in the double format, and you can see why. So even if the data set was much smaller, I mean, the chances of it being, this crazy long decimal is almost 100. So that was easy. That's that. Let's try another one. So let's go to the TQL reference. There's a time interpolated. So let's try that one. So let's go back to our shell. I have them saved here under tiempo. So I have time interpolated. Let's just copy and paste this. So basically, it just takes a column, which we're going to do carbon monoxide in this case instead of humidity, and then you just put in a timestamp. Here, I think this is one of the earlier timestamps of a data set. I kind of don't remember, but I'm going to do that, and this probably means nothing. So let's try a better example. So let's try to select all from device 2 and print every single result, which is going to be a lot of data. But I'm doing this so that we can have, so we can pick a timestamp to interpolate from. So let's go back to our query, and let's target, let's say, July 20th at like 3:20 in the morning. I think that's what that says. So let's change this to 3:20 in the morning of the same day. But since we obviously have the data for 3:20 in the morning, let's change it to 3:23 in the morning. So 3:23 in the morning, as you can see, doesn't have values here. This is a made up time, doesn't have values at all. But since I'm using time interpolated, it'll still grab me some kind of data. And even though this doesn't exist, GridDB does the math in the background to try to interpolate values that probably would be in this timestamp. So it uses the values from before and after to try to figure this out. So you can pause the video and try to compare the values. It's really hard because they have all these long digits in it, and I really don't want to, but feel free and let me know. All right, last one we want to do is time sampling. So here's the time sampling, and here's what it takes. It takes a column, and then time start, time stamp end, interval, and then you choose the interval unit, I guess you could say. So I have it saved here as well. So let's copy this, paste this here. So we're gonna go humidity again, humidity this time, because I think humidity has bigger numbers. CO is kind of really, really small numbers, which I guess is a good thing. The global warming sense of things. So let's see here. So we're doing a timestamp from July 18th, which is, as you can see, somewhere upper in the middle of the data set, through to 22, and we're going one day. So 22 doesn't make sense. Let's go to 20. Let's just go to 19. Let's go to 19, actually. I don't know why I had 22. And let's change this to hour. And hit enter. Okay, so it's giving us a time sampling between these two data points, July 18th through July 19th. It's the same time, and we did 1 hour. So that's 25 hours in between those, so we get 25 hours. So get this, and I'm sure if we look up, it's right. Really not that exciting. Let's change up how we want to do this. So let's bring up the entirety of the data set again, just to have it. And instead, let's try to grab a sampling of data that doesn't exist, right? So let's try, again, from this point. Let's try from the beginning of July 20th. And let's end it at the last data point we have here, which is 3 minutes and 36 seconds in. And let's sample by every 10 milliseconds. So let's see, this data already has pretty frequent updates, but it's nowhere near 10 milliseconds, right? So it's gonna provide lots of data. So we're doing 3.5 minutes of data, but we're going every 10 milliseconds, and we're gonna get that data set. So let's run this. And we get 20,000 rows, so that's more than I thought, but that's because I can't do this math in my head. Let's just get this. And
it's kind of a boring sampling because since the data is so compact, there's hardly ever any change in the data on the right, which, I mean, as I'm scrolling up, you can see that there's really no changes at all, and then it just changes here. So yeah, that's what time sampling does. You give it two time references, and it'll basically sample that data out for you and provide you with that data. So, yep, that's all. Thanks for watching.